Okay, let's discuss about the next question. Okay, this question I'm expecting for the tomorrow get one exam of DMB 3301 Thermo. Okay, now we are discussing about the tomorrow get exam. Uh, this the question. Today we are now going to discuss. Okay, read the question now. In a steady flow open system, in a steady flow open system, in a steady flow open system, a fluid substance flows at the rate of 4 kg per second. It enters the system at the pressure of 600 kilo Newton meter minus 2. Therefore, 600 kilopascal. A velocity of 220 ms minus 1. Velocity of 220 meter per second. Internal energy U. Internal energy 2200 kilojoule per kilogram. And a specific volume 0.42 meter cube per kilogram. It leaves the system at the pressure of 150 kilopascal. There is a kilometer, okay, uh, kilopascal, okay, kilo newton meter minus 2. Velocity of 145 ms minus 1. Velocity, second velocity. Internal energy, the second internal energy, final internal energy is 1650 kilojoule per kilogram. U2. And specific volume V2 is equal to 1.5 meter cube per kilogram. During its passage, now the fluid is passing from one place to another place. That is the question. That is the given data. During its passage through the system, the substance has a loss by heat transfer. Loss by heat transfer of 40 kilojoule per kilogram to the surroundings. What is the we already discussed in our past copy class videos. What is the how to mention this in symbols? Delta Q is equal to uh, okay, Q is equal to minus 40 kilojoule per kilojoule kilogram minus 1. This there is symbol. The substance has a loss by heat transfer of 440 kilojoule per kilogram to the surrounding. The fluid is fluid is moving the fluid is moving from one place to another place. Now, because of the flowing, there is a heat loss. That is Q is equal to minus because the heat is the, the heat is going from internal system to out the system, surrounding of the system. Okay, from the internal system to the surrounding of the system or outside of the system. Therefore, Q is equal to minus. If energy comes to the comes to the system, then Q is plus. If if the energy releases from the system, then Q is minus, which is less than zero. Okay. Now surroundings. Determine the power of the system. Determine the power of the system, stating whether it is from or to the system, from the system or to the system. Neglect any change of gravitational potential energy. Gravitational potential energy. Let's assume that, for example, the fluid may be flow like this. Okay, the fluid may be flow like this. Uh, like this. Sometimes the fluid may flow like this. Okay, sometimes the fluid may flow like in different. There may be here mostly the uh, the points are in same line, no, mostly. But we already studied in advanced level. If the fluid is going like this, like from here, from this the land, okay, then the fluid is going from down to upper side, upward. That time there will be a height difference, no, edge. Therefore, we studied in advanced level. We used rho g h equation, rho g h to the equation. We have to consider about the rho g h. But here they mentioned that neglect any change of gravitational potential energy. Neglect any change of gravitational potential energy. If there is a height difference, there will be a potential energy. But here they told that uh, neglect, we can neglect the change of gravitational potential energy. Now let's rewrite, let's mention everything again in symbol, okay. Now they already said that. So for example, this is the diagram, okay, because if you read the question in first uh, initial velocity is 220 meter per second, but the last final velocity of the fluid is 148 um, meter ms minus 1. Therefore, the initial uh, initial velocity of the fluid is higher than final velocity, final velocity of the fluid. Therefore, the the system may be like this, because here the area is narrow. Here the area is wide area, narrow area. Therefore, here this is a steady flow. Now we are studying about steady flow energy equation. In the first video we discussed about non-flow fluid non-flow energy equation. There is no flowing. We already discussed about it. There is no flowing of fluid. There is no fluid flowing in the no non-fluid energy equation. But here steady flow. There is a steady flow. Therefore, here if the if this is a narrow area, narrow area, this is the very wide area. Therefore, here the velocity will be higher than uh, the final velocity. Okay. Now we we write everything in symbols. Okay. In final stage, first stage, in initial stage, P1 is equal to, in first stage, P1 is equal to 600 kilo Newton meter minus 2, kilometer Newton meter minus 2. Okay, therefore P1 is equal to, if you want to, do the calculation in kilo, you can do in you can calculate the equations in kilo. But I recommend you, according to my experience, if you do the calculation in kilo, you may make any mistakes in any places. Uh, if sometimes you will not you may forget the kilo. Therefore, mostly uh, in my exam mostly I change to normal. I I I kilo instead of kilo, I just substitute 10 to the power 3. Therefore, we can write the P1 is equal. If you want, if you can if you can calculate using kilo, you can use kilo Newton meter minus 2 without substituting. But you may make mistakes. It's making mistakes is probability of making mistakes is very high in uh, with when we dealing with kilo. if you do the questions by yourself, you will experience okay. Now, let's move the question. They have 6 into 10 to the power 5, because 10 to the power 2, 10 to the power 3, 6 into 10 to the power 5 Pascal. 1 Newton meter minus 2. Okay, P1 is equal to 10, 6 into 10 to the power 5 Pascal. When I write everything and when I say anything, please write in your on your exercise book. Okay, therefore you can understand the flow quickly. Sometimes if you just watching my video, sometimes you can understand very well. If you write everything with everything on your exercise book with me, you can quickly understand. Okay, therefore please take notes like me. I also take notes for every cookie class. Okay, therefore P1 is equal to 6 into 10 to the power 5 Pascal. uh, the C, what is the initial uh, velocity? Initial velocity is 220 ms minus 1. 220 ms minus 1. Therefore, here we can i- flow at the rate of 4 kilogram second minus 1. That means the energy will, the fluid will go 1 second, 4, 4 kilogram per second. 4 kilogram per second. Therefore, for 1 second, 4 kilogram will 4 kilo 4 kilogram for 1 second. 4 kilogram of fluid will flow to the system. Okay, by through the system, 4 kilogram of fluid will flow. We have already studied in advanced level like this, 4 kilogram per second. Now they mentioned that initial velocity is 220 ms minus 1. Here we will not use v for velocity, because we will use the v for volume. There is a volume. Therefore, here we will use velocity. We use the symbol c for velocity. Okay. We already studied in advanced level chemistry. We used c for velocity. You may remember. Therefore, C1 is equal to 220 ms minus 1, 220 into ms minus 1 meter per second, 200 meter, 220 meter per second. Then the initial internal energy is 200 and 2200 kilojoule per kilogram, not kilojoule. If the internal energy is just 2200 kilojoule, we have to use capital U. But here they mention that uh, internal energy is 2200 kilojoule per kilogram. Therefore, we have to use a small u. Therefore, internal energy is equal to U1 is equal to 2200 kilojoule per kilogram. Kilojoule per kilogram. Kilo is 10 to the power 3. Therefore, U1 is equal to 2200 into 10 to the power 3 joule kilogram minus 1. Therefore, U1 is equal to, this is 10 to the power 2, no? 22 into, or 2.2 into 2.2 into 1, 2, 3, ne? 10 to the power 6 joule per kilogram. We mentioned in scientific notation. 2.2 into 10 to the power 3 joule per kilogram. Then they mentioned that uh, the specific volume at the initial stage, the specific volume is 0.42 meter cube per kilogram. 0.42 meter cube per kilogram. Here we will not use capital V, because here specific volume is 0.42 meter cube per kilogram. If the volume is 0.42 meter cube, we will use capital V. But here specific volume is meter cube per kilogram. 1 kilogram is 0.42 meter cube. Therefore, we will use small v here. Therefore, V1 is equal to small v, not V1 is equal to 0.4. Please write on your rough paper or in your exercise book. Okay, 0.42 into 42 meter cube kilogram minus 1 meter cube per kilogram. Uh, Now we have mentioned we have written all the aspects of initial stage. Now we are going to move to the final stage. In final stage, the what is the pressure? There is now okay. Now it leaves the system at the pressure of 150 kilopascal. 150 P2 is equal to 150 kilopascal. Therefore, P2 will be P2 is equal to 1.5 into 1 5 into 2 10 to the power 5 5 Pascal. 1.5 into 10 to the power 5 Pascal. Then the initial voltage is 100. Final velocity is 145 ms minus 1. Therefore, C2 is equal to 145 meter per second. 145 meter per second. Then they mentioned that the internal energy of the final stage is 1650 kilojoule per kilogram. Therefore, U2 is equal to 1000 and 1650 uh, kilojoule kilojoule per kilogram. They have kilojoule per kilogram. There was small u. Okay, small u. U2 is equal to 1.65 into 1.65 into 10 to the power 6. 65 into 10 to the power 6. Okay, joule per kilogram. This is the internal energy at the final stage. Now we have to find specific volume. What is the specific volume? Specific volume is 1.5 meter cube per kilogram. Therefore, V2 is equal to 1.5 meter cube per kilogram per kilogram. Now, now we have mentioned uh, we have written all the aspects mentioned in the initial stage and final stage. But we have to now we have to mention the heat. Okay, 1.5. Okay, now during its passage through the system, the heat transfer velocity is 40 kilojoule per kilogram. Therefore, energy lost. Therefore, Q is equal to minus 40 kilojoule per kilogram. Kilojoule kilogram minus 1. Therefore, Q is equal to minus 4 into 10 to the power 4 joule per kilogram. Okay, now uh, what's the now we are going to find the answer. Determine the power of the system. Now we are going to we have to find the determine we have to determine the or find the power of the system. Let's find how to find it. First, we are studying about steady flow energy equation. Steady flow energy equation. Already we studied non-flow energy equation. Here we are studying about steady flow energy equation. Steady flow, steady flow energy, steady flow energy equation. Okay, steady flow energy equation. Oh, what is the steady flow energy equation? We have already studied the non-flow energy equation. What is a non-flow energy equation? Non-flow energy equation is Q is equal to delta u delta u plus w. This is the non-flow energy equation. A B C D E F G H I J K L M N O P Q R S T U V W. Okay, this is the small trick to memorize. Okay. Now, what is the steady flow equation? What is the steady flow energy equation? Energy equation. What is the steady flow energy equation? That is U1 plus P1 V1 small v. Okay, U1 plus small u. We have already discussed about U1 plus P1 V1 plus C1 square by 2. U1 plus P1 V1 plus C1 square by 2 plus Q. Q is equal to U2 plus U2 plus P2 V2 U2 P2 V2 plus C2 square by 2 C2 square by 2 plus W. This is the steady flow. Please, okay. This is the steady flow equation. U1 plus P1 V1 plus C1 square by 2 plus Q is equal to U2 plus P2 V2 plus C2 square by 2 plus W. Here U1 plus P1 V1. Here U1 plus P1 V1 and U2 plus P2 V2. They are same, no? What are they? What are they? They are enthalpy. 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 We have already studied in advanced level chemistry. Enthalpy. Okay, enthalpy. What is the C1 square by 2? What is the C1 square by 2 and C2 square by 2? They are kinetic energy. Kinetic energy. Uh, yesterday said uh, taught us about that. U1 plus B1 V1, U2 plus B2 V2 are enthalpy. C1 square by 2, C2 square by 2 are kinetic energy. Sir yesterday told us. Okay. Now, sir mentioned that don't confuse. We already discussed about non-flow energy equation. Now we are studying about steady flow energy equation. Say that don't confuse with non-flow. Don't confuse. Non-flow equation is different. Steady non-flow energy equation and steady steady flow energy equations are different. Therefore, say that don't confuse with the equations. You must apply the equations very carefully with correct equation. Okay. Then uh, then okay. Let's move now. For how according to the non-flow energy equation, Q is equal to delta U plus W. We have already discussed. No, how to here. This is the non-flow energy equation. Q is equal to delta U plus W. Here U is what is meaning? Q is equal to U2 minus U1. No, right? Q is equal to U2 minus U1 plus W. Okay. Here for the steady flow equation, we have to sum something. That is from for the left side, we have to sum something that the half C1 square, half one half C1 square. This is the kinetic energy. Then we have to add P1 V1. This sorry, this is capital P. This is small v. Okay, P1 V1. We have to add for the left side. We have to add for the right side. You now please remember, first if you don't if you forget the steady flow energy equation, first write the non-flow energy equation, which is the non-flow energy equation. Q is equal to delta U plus W. Therefore, Q is equal to U2 minus U1 plus W. Okay, now we are going to derive the steady flow energy equation from the non-flow energy equation. Therefore, we have to add something from left to right. Okay, if we add something from left to right, uh, the same thing. If we add some same thing, the the final answer will not be changed. No, this is some tricks. Okay, for the left side we get half c1 square plus p1 v1. Okay, half c1 square, half c1 square plus p1 v1. Here for the right side we have to get same thing, half c2, half c2 v2, half to c2 square, half c2 square plus P2, V2. We already discussed in our past QP classes about P1, V1 also energy. Here U2 minus V1, enthalpy. W is energy, Q is energy, half C1 is kinetic energy, K1 kinetic energy, enthalpy. Okay, work done. Input energy, output energy, Q. Okay. Now let's now we have derived the steady flow energy equation from the non-flow energy equation. Therefore, Q plus Q plus half C1 square, half C1 square, Q plus half C1 square plus P1 V1 plus P1 V1 plus this there is a minus U1 in the right side. I am going to move the minus U1 from right to left. Therefore, it will be become plus U1 at the left side. U2 U1. Therefore, in left side q plus half c1 square plus p1 v1 plus u1 is equal to left side u2 plus w plus u2 plus w plus half c2 square plus p2 v2, half c2 square plus p2 v2. Now we have derived the steady flow energy equation from the non-flow energy equation. Q plus half c1 square, q plus half c1 square plus p1 v1, q plus half c1 square plus p1 v1 plus u1 is equal to u2 plus the w plus half c2 square plus p2 v2. Okay, but for the beauty of the equation, we write in like this, u1 plus u1 for the beauty, u1 plus p1 uh, p1 v1, u1 plus p1 v1 plus c1 square by 2, u1 plus p1 v1 plus just we move here and there. Okay, we didn't change the equation. u1 plus p1 v1 plus c1 square by 2 plus q is equal to u2 plus p2 v2, u2 plus p2 v2 plus c2 square by 2, c2 square by 2 plus w, u1 plus p1 v1 plus c1 square by 2 plus q is equal to u2 plus p2 v2 plus c2 square by 2 plus w. Here u1 u2 p1 v1 p2 v2 c1 square by 2 c2 square by 2. Here q w. Now we have derived the steady flow energy equation from the non-flow energy equation. It's most if you can quickly memorize the steady flow energy equation directly, you just memorize this. Mostly I don't like. Mostly I never memorize everything. Mostly mostly I find any tricks to memorize. Uh, I just memorize Q is equal to delta U plus W, delta U plus W. Therefore, I will derive this from that. Okay, if you uh, please memorize in your way. This is my way. Okay. Now the question is power of the system. No, power output of the system. Power of the output of the system. First, we have to consider about. We know power is equal to. We already know power. Power P is equal to work done. Work done. W. Work done W by time t. We already studied in advanced level physics Not only I think in grade 9 physics also, guys, science grade 9 physics at the grade 9 physics also physics in science subject also we studied this power value is equal value summon வேலைங்கில் நேரம் in Tamil value summon வேலைங்கில் நேரம் in English power P is equal to work done W by T. P is equal to W by T. Someone asked that please conduct the someone request me to conduct the classes cooking classes in single or in Tamil, but really I don't know single. I only know English and Tamil. Okay, I don't know single. Okay, P is equal to W by T. Now we need to find the power of the power. We need to find the we have to determine the power of the system. Power of the system. Therefore, we can find the power using our W. If we can find the W, we can find the W first using our steady flow energy equation. There is W. This the W, no. Therefore, we can find the W using the steady flow energy equation. Therefore, we can find the power. We okay. First, we have to find the W. We studied that the steady flow energy equation is U1 plus P1 V1 plus C1 square by 2 plus Q is equal to U2 plus P2 V2 plus C2 square by 2 plus W. Please write at anywhere. Okay. Now, therefore, W is equal to if you if you now we are going to take the W for left side to find W. Therefore, just moving here and there. Now we move all the other things to right side and get the W to the left side to find the W. It's very simple, no? W is equal to U1 minus U2, U1 minus U2 plus P1 V1 minus P2 V2. W is equal to U1 minus U2. Internal change, internal energy, but not delta U minus delta U. Here P1 V1 minus P2 V2. This is also the energy difference. C1 square by 2. C1 square C1 square minus C2 square by 2. We just move to the right side. That's the thing. C1 square, but if you write on anywhere, you will quickly understand. If you just watch the video, you may confuse about what is this. You please write, okay. If you want to understand, please write, okay. C1 square minus C2 square by 2 plus Q. Now we have to substitute everything. We know U1. We know U1, U2, P1, V1, P2, V2, C1, C2, Q. We know everything. Therefore, W is equal to what is the U1? U1 is use okay. I quickly if you substitute the values to the this equation, we already discussed about what is U1, what is U2, P1, V1. We already discussed everything. Q is equal to minus 40, 40 no. Yes, Q is equal to minus 4 into 10 to the power 4 joule per kilogram. If you substitute to the this this if you substitute here the real values instead of these English letters for C, so if you finally get the final answer for work is your work will be I will not it's a very small thing, no, we don't need to extend the length of the video. Therefore, you just have to do you what is U1, what is U2, substitute, you will finally get the answer for W will be 550 550.699 kilojoule per kilogram. Kilojoule per kilogram. W is equal to 550.69 550.69 kilojoule per kilogram. This is plus, no, this is plus. Therefore, W is plus. W is plus or greater than 0. Therefore, work is done. Work is done. We already discussed about. Okay. Now we have find the W. W is equal to 550.69 kilojoule per kilogram. W is positive. They have a power output from the system. W is positive. W work done. Work done. W is positive. Therefore, please write at the exam. This, okay. Please write this. W is positive. Therefore, power output from the system. Power output put from the system. For example, uh, uh, we we pour 1 liter petrol to the bike's engine. Okay, bike tank. We 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 give 1 liter petrol to our engine. Okay, bike's engine. Therefore, it will do some work. No, that is this. W is positive mean power output from the system. The engine is system. Power output, we get power from output. That is the meaning. If the what is the meaning of W is positive is the meaning of W is positive is power output. Power output from the system. Power output from the system. If W is negative, power input for the system, because we input the energy to the system. We input the energy to the any or system. Here W is positive. Therefore, the system um, did some works. The system worked. The system worked. Okay. We can say in many way. That's why I say in many way, because if they ask in any way, you have to answer for the question. They may ask about power output or anything. Okay, that's why I say you in different English. Okay, therefore power output from the system. We get power from the system output, which means we get. Okay, now they in the question they said that now we have find the power W. W is 550.69 joule per kilogram. Therefore, now we can find the power. How to find power is equal to already discussed. Power is equal to work done by time. Time. Okay, time small t. Okay, mostly we use small t. No, power is equal to W by T. Power is equal to work done by time. What is the work done? Work done is equal to we all 550 point 69 506 point 550.69 kilojoule per kilogram for 1 second. Now we already know power, joule per second. The unit of the power is we already know joule per second or W. Okay, joule per second. We have to find the final answer from joule per second. Here we have to remove the kilogram. What is the meaning? Here we already know joule per second. What is the meaning? What is the joule per second? What is the energy for 1 second is there? What is the work done? What is the work done per second is the power? We already know. Therefore, P is equal to W. W is 550.69 kilojoule per kilogram. Per 1 kilogram, 550.69 kilojoule. We have to find what is the kilogram. For 1 kilogram, the work done is only 550.69 kilojoule for 1 kilogram. Now we have to find the total kilogram, total weight. How to find it? They gave oh, in the question they mentioned that they gave the data here. Where is it? Here, first given data. The flow at the rate of 4 kilogram per second. Therefore, for 1 second 4 kilogram. For 1 second 4 kilogram. Okay. Now here we, for 1 second, now we are going to find the total energy for 1 second to find the power. That is the power. Therefore, P is equal to 550.69 kilojoule per kilogram. Therefore, 1 second for 1 second 4 kilogram. Therefore, we have to multiply by 4 kilogram. 550 550.69 kilojoule per kilogram into 4 kilogram. That is the total. Because we find the power, you always find the power for 1 second. How much how much work is done for 1 second? That is the power. That is the meaning of power. Therefore, for 1 second we are finding. We don't ask that how did I get 1 second. This is the common. We always find the power for 1 second. The hour for 1 second. What is the total energy for 1 second? 4 kilogram of fluid. 4 kilogram. 4 kilogram of fluid will flow through the pipe for 1 second. That is the meaning. Therefore, total kilogram is now kilogram and kilogram will be cancelled. Now we have grabbed the unit of power, kilojoule per second. Therefore, P will be 550. You have to multiply 550.69 into 4. No, if you multiply 550.69 to 4, you will get the final answer 2202.76 kilowatt. Kilowatt. Okay, there is kilo. No, there is here is kilo. Don't forget this kilo. If you write, just write 2202.76, that is wrong. Because the answer is 10 time 1,000 times uh, bigger than bigger than your answer. Therefore, it's very wrong. Therefore, don't forget this kilo. Therefore, these are common mistakes, very small mistakes, but commonly most students make mistakes in these areas. That's why I told you the above is equal to 2202.76 kilowatt. That is the power output from the system. Therefore, please write. Therefore, if you have time, please write. This is the beautiful way for engineering students. Therefore, output from the system, because the final answer is this is no. Therefore, if you write like this, it will be very useful, very beautiful. You may admire our examiner. Therefore, output from the system. Therefore, output output power or power output. Therefore, power output from the therefore power output from the system is equal to from the system. Therefore, power output from the system is equal to then 2202.76 kilowatt. This is the final answer. Okay, this is the final answer. Now we have find the total answer. Is there anything we have to find? Okay, determine the power of the system. Okay, we have found the power system. Now what they are asking? They are asking again, stating whether it is from or to the system. From the system or to the system. What is power output? We already discussed, because W is plus, W is greater than 0. Therefore, from the system. That is the power output. We already power of the system. We already mentioned that output power of the system. Okay. Therefore, we answered for the power of the system. Right again. It is a power output from the system. Neglect any. Okay. Now we have found all the answers. Okay. Okay. Bye. Now, congratulations for your get exam. In next video, let's meet. Okay. Bye. If you like the video, please like and subscribe. Okay. Thanks so much.